In this lesson, we'll talk about neutralization, and we want to mention what neutralization is, and when it comes to acids and alkalis as well as bases, and how we can carry out neutralization. Probably we'll look at some chemical equation, what's involved in neutralization. So all you know, neutralization is a reaction between an acid and an alkali. When these two are added together in correct amounts, in a neutral solution is formed, and that solution, that is where the name neutralization comes from. So an acid and an alkali will react together to give a neutral solution. So neutralization is a reaction between acid and base to form salt and water. So what's important here is what forms out of neutralization. Is that out of neutralization you're going to have a salt and water forming. So we can start from the different equations, and we knew from the earlier discussions that an acid involves hydrogen ions or has hydrogen ions. This is the symbol for hydrogen ion, so which is H with some plus, hydrogen ions. So in acid we are going to find these hydrogen ions, and then in bases or an alkali we have from hydroxide ions from alkali. So these are the hydroxide ions from alkali. So these two ions react to give us water. They combine to give us water. So this one comes from an acid. This one comes from an acid. And the hydroxide comes from a base. The hydroxide comes from an alkali, which is a soluble base. Sure, by now we know what's the definition for an alkali. So we've got an acid producing hydrogen ions in dissolved state, and alkali producing hydroxide ions, and together when these react they give us water. So what's important for us is to note the chemical reactions that take place between an acid and a hydroxide and an alkali, which is basically reactions between hydrogen ions and hydroxide ions. So some of the examples we can look at, we have got when we talk about acids previously in the other lesson, we had talked about the three most common laboratory acids. Number one, we had talked about hydrochloric acid. Then we had talked about sulfuric acid. So these, and of course they have to be in aqueous state. And we also had talked about nitric acid. But probably these are the most common lab acids that we'll find in the lab even when you're doing experiments. Now these acids can react, according to the definition of a neutralization, is that they can react with an alkali to give us salt and water. Now the common alkalis we've got sodium hydroxide and calcium hydroxide and ammonium aqueous ammonia. So let's look at some example equation on how this all happens or it goes about. So here we have got sodium hydroxide reacting with sulfuric acid. So you have to note the words or the names of the chemical symbols for these chemicals of these substances, for the acids as well as for the alkalis. So we know that when sodium hydroxide reacts with hydrogen sulfate, this is an acid. Here this is an acid, and sodium hydroxide is an alkali. So we have an alkali reacting with, this is an alkali here, this is an alkali reacting with an acid here. So we know that the reaction between an acid and an alkali is called a neutralization reaction. It gives out two things. It produces a salt and it produces water. So the salt which is being produced here is sodium sulfate, and the other product is water. This is an example equation on the reaction between sodium hydroxide, which is an alkali, and hydrogen and sulfuric acid, which is of course an acid, and we've got this sodium sulfate forming here to giving us water. So you might remember this equation or learn how to write it down, and probably up to this point I assume you are comfortable with writing chemical equations. The next we have sodium hydroxide, which is in aqueous state. So these we can proceed to say that they are aqueous. They are in aqueous state to show that this is dissolved and that one's dissolved. So next we can have sodium hydroxide reacting with, probably it's the same. Okay, we can have sodium hydroxide, maybe this time we can say reacting with sodium hydroxide in aqueous state. Say it reacts with HCl or hydrochloric acid. This is the base in an acid, reacts. This will give you sodium chloride, which is aqueous, plus water. So these are the chemical equations. This is the chemical equation for reaction between sodium hydroxide and with water, of course, being a liquid. Okay, so this is the reaction between an alkali and an acid. So it gives you the big takeaway from this one, that it gives us salt. It gives us salt and water. When an acid reacts with an alkali, we have a salt and water. And these are some of the example chemical equations. Next, probably we can discuss the Ionic equation of these reactions, like what really goes on what really happens when everything is happening. So we had already mentioned that this is what is happening. So the acid is donating a hydrogen ion, and then we have the alkali giving us the hydroxide ion. So this hydroxide ion comes from the alkali, and then the hydrogen ion comes from the acid, and they give us water. I don't know why we have, so giving us water in liquid form. That is water there in liquid. So when, for example, we can have situations where we need a neutralization reaction to happen. Farmers, for example, we've got the soil which is acidic, and the plants won't do well if your soil is acidic. So sometimes they get what they call quicklime, which is just calcium hydroxide, and we know that calcium hydroxide is an alkali. So that calcium hydroxide is added to neutralize the salt, because we know that a neutralization reaction is going to happen to give us a much less, if not harmless, chemical, which is water. So we're going to have calcium hydroxide reacting with the acid in the cell to give us a calcium salt plus the harmless product, which is water. So this is how we can use chemistry in real life. So we can apply chemistry in farming to neutralize the soil. When the soil is acidic, we can add quicklime, which is calcium hydroxide, to neutralize the acidity of the soil, and that is which follows this equation here. Alright, so this is just about neutralization reaction. Big takeaway that it is a reaction that happens between an acid and an alkali to give us salt and water, and on a much more focused level, this is what is happening on this ionic equation. The hydrogen ion is reacting with hydroxide ion to give us a molecule of water.